Coordinator for Student Projects at Fast Forward, which is also a part of Johns Hopkins Tech Ventures. And so a little bit of logistical info about the top 10 presentations themselves. Each team will get 4 minutes to speak, no more. I will be cutting you off at 4 minutes, but you will have 1-minute warnings as well as 30-second warnings from our guys in front. So please be mindful of your time. After the presentations, we're going to be awarding the sponsor prizes. And after that, the judges will return and we will continue to the final top 3 grand prizes. And so with that, I'm actually going to announce our top 10 finalists. Number 1, this is in order of presentation. We have Tip of the Tongue. Tip of the Tongue, are you here? What? Oh, please come up to the stage and sit on your right-hand side, my left-hand side, in front of the podium. Next, we have Portnort. Portnort, where are you? Please go to the left side of the stage. We have 2 a.m. is next. 2 a.m., are you here? Please come sit up front in front of the podium. Next up, we have HealthMate. HealthMate, you're on the right-hand side, or left-hand side. We also have Lexicon. Lexicon, are you here? Great, come up front. We have Handy. Handy, are you here? Woo! My Own Jam, please come up in front of the podium. My Own Jam. Touch Plus. Touch Plus, please go over there to the left. The Force Ghostwriter, please come up to the front of the podium. And Soteria, please go to the left. All right, guys, these are our top 10 finalists. So we're going to start off with Tip of the Tongue. Whenever they're ready, please come to the front.
I have everyone's.
Okay, so this is the microphone you're going to be using. You have to hold it really close to your mouth. Okay. Not too close, so you guys have a lead.
Lecture. Lecture. I think, do you have to press anything, or is it just hold it?
Okay. Hello.
All right. Whew. All right. Hello. Our project is called Tip of the Tongue. So I don't know if you guys have ever been in this situation. But this is something that happens to me all the time, where I'm trying to think of a word, and instead of the word I was trying to think of, I can only think of 5 other very similar words. Now, like, my mind is completely blocked. I can't think of the thing I was trying to think of. A tool to help a person out who's in that situation. So the very basic idea is, unlike a traditional thesaurus where you use one word to search for like all the synonyms for that one word, you can do multiple words, and it'll find basically sort of like the overlaps in words related to those words that you put in and return those as the top results. So for an example, say you were trying to think of the word jaded, only that's sort of a complicated word, you can't remember it, so you can only remember tired and cynical, which I think some of us are probably feeling at the moment. Yeah, so we have a live website with this tool hosted. You can draw from various data sources, get different numbers of results. So in this case, jaded comes up as the first result. So for a happier And yeah, it also will return a GIF related to the words that you searched for. That woman looks extremely jaded. So a happier example, say you're looking for a complicated word meaning like hopeful, optimistic, happy. Sanguine, which is this complicated Latin word that most people have trouble remembering most of the time. But it's an interesting word. You have an opportunity to use it. In addition to the regular thesaurus and the image search, there's also an option to include data from Urban Dictionary. Very good. So basically, by leaving the Urban Dictionary by default, that's sort of like our safe search. So why don't we take some suggestions from the audience? Anybody have any ideas for that word that you're trying to think of, or the cloud of words related to that word, rather? Hack. Let's hear another couple of related words. Creative. Innovative. Let's see what we get. Hack, yeah, that's what it is. What's the image?
I think they're like that feeling.
Yes. So you want to tell them about what's...
Okay, so the algorithm that's actually doing this, we with it over the weekend, implemented starting on Friday. So it gets, the basic version of it is it will look through the source, it will get all the synonyms for the word, and then all the synonyms for the synonyms, and so forth to whatever depth you specify. And basically, for each word, we'll create a cloud based on those words. The current version of the algorithm creates like a histogram from that cloud. The count, basically, the return value is like a dictionary with the words as keys and the counts as values. And then you, for the different sources, you take the z-score of each of those histograms, can combine them to get like a reasonable weighting between disparate sources of information. Probably shouldn't show off the Urban Dictionary search for the presentation, though, unfortunately. But you guys are welcome to take a look at it on your own computers. It's live hosted on AWS, live website. We have a copy of the QR code?
No, but you can use the dev post to get the...
Yeah, it's linked on the dev post. And sometime next week when our DNS servers resolve themselves, it'll be available at tipofthetongue.tech for all to use.
Portnord, are you ready? Okay, we'll go to the next one. 2 a.m., please come to the podium.
Hello? Oh, it works. Hello, everybody. We're 2 a.m. We came to this hackathon with an idea to create a simple app that helps users evaluate how impaired they are after drinking alcohol. So we took a very unorthodox approach to creating this app. On Friday night during the actual hackathon, Himanshu and I went out to the freshman dorms and met both sober and inebriated people. Conveniently, it was rush week. And we asked them to perform 3 very simple tests for us. One was the vertical line test with a gyroscope. And these are the results that we got for just the x-axis. As you can see, the sober individuals had a much more steady results compared to the intoxicated individuals. And we also asked them to perform a reaction test and also a hand-eye coordination with texting. And all the results reflected that The more you drink, the less coordinated you are, and we use those data to inspire us to create our app.
All right, so next slide, please. All right, so let's take you through the app. So we have a basic backlogger so you can watch your back, all right? So here you can track all the drinks you take in a night, if you do drink. Go back for a second. So you can, the nice thing about this is that instead of just calculating what your instantaneous blood alcohol content level is, you can also figure out when you're going to be sober. So you can also make decisions based off of that. Can I get the next slide, please? You can personalize it, so your age, weight, and gender, so the algorithm will calculate your blood alcohol content correctly. And you can also create a custom drink. Maybe you like Everclear and you just want to put Everclear in there. And you can set the Everclear for you, 151 proof. Enjoy. All right. So the first thing you're going to do is something called the line walk test, much like a regular police test. So you're going to do something like you're going to hold your phone out here and you're going to walk forward like this. The gyroscope is actively reading the sensor and it tells you to walk for about 20 seconds. That's 100 data points. If you're outside the variance for 5 of these data points, you're probably drunk. And I mean that seriously. We actually have a 100% accuracy ratio, and we've tested this a couple hundred times now on drunk people and on sober people trying to act drunk and sober people trying to act sober. So let's get the next slide, please. So you have a typing test, which is coordination, and all people's like, oh yeah, drunk texting is hard, so we made it into a test. So you get an app, and it's a randomly generated string that you enter into the app, and then it tests your words per minute, like Mavis Beacon kind of thing. And then once it has those words per minute, it will save those words per minute and make a value judgment later. All right, and then there's a reaction test that changes colors, and then you press it. It's like blue to cyan, which is kind of hard. And here's the result. If you're intoxicated above the legal limit, it will tell you you're intoxicated. Even if you pass the other tests, you might not necessarily be okay. So here's a demo of the app. So, all right, so this right one over here, this is a sober person. Over here you have a drunk person. So the line walk test will record and speed it up a little bit, please. Okay. Okay, anyway, so the line walk test will compute, and then afterward you'll get your personalized information about if you're intoxicated or not. And we really believe that nothing good ever happens after 2 a.m. But with 2 a.m., we've got your back.
Thank you so much, 2 a.m. That was great. On deck, we have HealthMate. HealthMate? Up right now. We have Lexicon on deck.
All right. So at this hackathon, we built an app that has several $1 billion on the line. And what we're talking about is healthcare noncompliance. When a patient goes to the doctor's office and the doctor gives them sometimes a simple list of self-care objectives, and the patient goes home and simply doesn't do them. And this is associated with a very significant loss of life and loss of revenue. And it's a very serious problem. So we wanted to find a solution.
So the solution really needs to be multidimensional in that it addresses the challenges with medical professional side as well as the patient side. So on the medical professional side, it's important to find a method to collect data for doctors to track patient adherence throughout the entire treatment process. And on the patient side, it's important to address challenges such as forgetfulness and difficulty understanding large, complex, or drug treatment plans. And so on the patient side, we're able to do this by direct reminders or explaining the drug descriptions in more detail, but we're also able to harness something called the white coat adherence theory. And this is a psychological study that has shown that as the days get closer to the medical appointment, patients adhere to the treatment plan more readily. And so if we're able to mimic the same doctor presence throughout the entire treatment plan as opposed to discrete time points, we'll be able to increase patient adherence.
Okay, and so in order to incorporate all these factors into one simple compiled object, we decided to create an app called HealthMate. And as we get the demo started up here, this HealthMate app has two different interfaces. There's one for the patient portal, one for the doctor portal. Wait. And so, sorry. Yeah, as we log into the patient portal here, first thing you can see right in the middle is your list of tasks. And what you can do is you can go through your list of tasks, say if you've done them or if you haven't done them, and by the end of the day, you should get to some sort of screen that looks like this, the all task complete screen. We have several other widgets, including the calendar. This is just a place for the patient to be able to see tasks that the doctor has assigned to them, maybe in the future, maybe in the past. We have a text version of that. We call that the agenda. It's basically the same thing based on user preference. The coolest thing about this is we have the statistics thing where we can track, patients and doctors alike can track patient progress in terms of the tasks that they've completed. So in this example, let's say they've completed a task 80% of the time for the past month. And patients and doctors can see this same exact graph. And in this one, the bar graph, we track the weekly progress as well. And the last little note for the patient side is the doctor's notes. And this is just a place where the doctors can describe in more detail what the tasks actually are and any other information that the doctors might have for the patients. And so now we're logging into the doctor portal, and we're going to walk you through that.
Yeah, so here you can see the doctor has a list of their patients. If you press the plus sign, you can see, oh, this patient isn't associated with any doctor, so we can add them if we want to. So if we click on Erica, we can see the task that we assigned to her. And when we click the task, we can see how she's been doing on a week-to-week basis. And you can also add tasks as the doctor.
Thank you.
All right, thank you.
Thank you so much, HealthMate. Up now we have Lexicon and Handy. Handy, you are on deck.
Okay, hi everyone. Today I'm going to present the app called Lexicon, and I want to start by asking all of you a question. Have you ever tried to learn a foreign language? Anyone, any language, like Spanish, Russian, German, doesn't matter. Yes? You did? Which language? German. Das ist sehr gut. Danke. Okay, when you're learning a language, doesn't matter which one, you're referring to textbooks or language learning software, which usually relies on sections based on some kind of theme. So let's say food or restaurant or transportation. All the textbook are structures this way. So we decided to take this idea to the next level by bringing interactivity to the process of learning. So our app, Lexicon, it understands where you are and gives you useful words and phrases in the language you learn based on where you are. Let me run a little demo. Not here. So, using Foursquare API, the app automatically understands in what place you are and gives you suggested words and phrases which we can use to explain yourself with locals. And that what is like basically allowing you to learn new vocabulary using your surrounding. For example, here I have a Russian set up as targeted language and English as my primary language. So you get some useful phrases for you to explain yourself in Russian in a university context, something like how they get to the library or like where's the nearest building or something like that. All the words that you unlock based on location get saved in the history tab. So in the future, you'll be able to revise the words that you unlocked. And we encourage people to discover more locations by having a little bit of gamification element. So you actually have to unlock unlock all the locations to complete the progress bar, even though it's a little broken. And we have in plans. We're planning to add some additional languages such as Spanish, Italian, German, and also add speech-to-text and text-to-speech APIs to make it easier for you to learn how to pronounce words and actually practice pronouncing them. So that's Lexicon.
So wait, guys. So yeah. So my teammate and now friend, Elliot. So she just talked about the prototype, right, of Lexicon. So my part is to talk about what we will do in the future. So the world is becoming more connected now, right? So you know, Elon Musk, the founder of SpaceX, is working on reusable rockets now. So one day we might need to learn how to communicate with alien life, right? And then you know, Google's AlphaGo just beat a professional player in the board game Go. So maybe one day we might need to learn how to speak to an AI. Maybe say, oh, print hello world, or maybe see out hello world. Oh, syntax error. So yeah, this app will be really useful, and we will definitely add more features to it. For example, like text-to-speech or speech-to-text capabilities. And we'll definitely bridge the gap between, in-class learning and reading as well. Because, when you go to a class, right, you listen to the professor, talk, but you don't really get to, like practice using the language. So this app, if you go to Madano in Tokyo, you don't know how to speak Japanese. It would just give you a list of the most common phrases and words. Yeah.
Sorry about that. Good job, guys. Thank you very much, Lexicon. Up now we have Handy, and My Own Jam is on deck. Handy, please come to the stage.
Hey everyone. So our project, can everyone hear me? Yeah. Okay. Our project was to integrate the camera on most everyday computers to analyze people's hands so that we could find out what position they're in so that patients who need hand therapy can do it at their home instead of visiting the clinic or visiting their doctor. So this saves time for them because all you need is a camera, which virtually all computers have nowadays. You don't need any external devices, and you can do it at home, which is especially good for people who can't drive. Furthermore, you can add motivation to it because you can incorporate a game, which is kind of difficult to do if you don't have accompanying system. So we're going to give you a demo / intro into how we did the data analysis and computer vision for it.
Yeah, so we're going to do a quick demo of a simple UI we made. So this will kind of give you.
Logo, by the way.
Yes, this will kind of give you some. This will kind of give you some insight into what we did. So as you can see, obviously it analyzes. So we used what's called OpenCV. It's a common library for image processing made for C and C++. And we used it because we wanted the functionality of C while still doing our coding in Python, which is, easier and integrates numbers. So for OpenCV, not only can you capture the images, not only can you do simple analysis, but you can also kind of do some great backfile work. So I'll let my friend here talk about some of the...
Yeah, so there are two biggest challenges we face, and the first one is the data issue. We have 360 pictures of hand motions, and we chose the best of 450 pictures. But even for that, we have to stretch out because each picture is a matrix of pixels. In order to analyze on it, we have to stretch out each picture to a line. So so for each picture, we have about 160,000 variables. So that's about, so all the pictures together, it's about 1 gigabyte data. So it's a big issue for us. How we do it is we encode the image into bitmaps. So for pixels bigger than 127, we encode it to 1. Less than that, we encode it to 0. So there's a big sparse matrix that we can analyze. We can use algorithms to analyze it. The second issue is that we want to make the respond real time, so to the hand motions that user use. So what we did is to use k-means clustering analysis to classify the hand motions, and we use EM algorithms, basically a Gaussian mixture model to improve, and an ensemble method to improve the accuracy to about 70%. The reason why it's real time is because when users use it, they take a picture and they convert it to bitmaps, and they will to see which the data is closer to which cluster the data is closer. The more closer it is, the more likely it belongs to that cluster. That's how we classify the users.
So you can see on the left, it's giving out numbers, each number representing a specific emotion based on the picture given from the camera. And thank you guys for listening.
Thank you, Handy. Up now, we have My Own Jam, and Touch Plus is on deck. My Own Jam. You got it?
All right, so hi, this is my own jam. So one of the main limitations today on pedometers is that, like, if you're wearing one on your wrist and you're shaking your hand, then it's going to count that as a step. So what we wanted to do was have something that's going to count your steps without having that inaccuracy. So we use EMG sensors in the myo, and that's going to sense your electrical signals in the muscles. So that knows when he's moving his muscles in his legs, that's going to count a step. We have a different threshold. So what our program does is it counts steps per minute, and then it matches that up with a song that has a similar beat per minute, and it plays that song. So it's primarily for like runners and stuff.
So, hi, I'm Vijay, and we both are from Johns Hopkins, and these are from University of Maryland College Park. So we met here on the first day, and we came up with an idea wherein we wanted to, use EMG. EMG is basically electromyograph, so it gives the electrical activity of the muscles. So what we wanted to do with that was use the EMG in order to, detect the muscle tension or like measure the muscle tension and, give a vibration feedback for people who are like athletes or weightlifter, for example. Like, how many people here lift weights or like? Yeah, so there are so many of them, and they usually lift weights without knowing that if they are like overlifting the weight or not. So they just like randomly go and, I have the capacity to lift this weight, okay, I'm going to lift it, and then the next day they're facing the fatigue. So we wanted to, come up with a solution which can help the weightlifters or the athletes, and we actually, like, none of us have the computer science background, so we did everything on MATLAB. Yeah, we'll do the demo as well. Oops.
Okay, so I think we'll give you the demo first. So our friend here is going to walk and change his pace, and we're going to show you hopefully if the MATLAB doesn't crash, it's going to run, and we'll actually show you changes in music. So, yep. And we're starting. So there's a small delay usually to figure out the first pace at which he's walking.
Is the volume off?
Yeah, it is. He's speeding up, so it should change, hopefully. We're sorry about this, but so the problem with the MATLAB is there's a lot of cache that it keeps storing, and we don't know how to get rid of it. And then what happens is we have to end up changing we have to restart the entire system for that.
So that's like the kind of what we came up with the time that we had, but this is something that we did offline, so wherein we stored the data from like one of the experiments wherein I was like trying to fatigue myself, like I was holding my fist really hard for a minute, and then slowly like I was recording the data from the myo, and you can see the tension builds up, and for some time it stays high and then it slowly comes down. So if we get like help from different iOS or Android developers, we can like try to code this on mobile devices and give a vibration feedback through the myo in order to tell them, hey, you're lifting a lot of weight, you should like slow down. So
yep, that's about it. Thank you.
Thanks a lot.
Thank you, my own jam. All right, Touch Plus, you are up now, and the Force Ghostwriter, you are on deck. Do you want 2 mics or one?
Hello, everybody. So we're 4 undergraduate students from Johns Hopkins, and we realized something very important to us, in this world that there's actually 285 million people who are visually impaired, and 39 of them are completely devoid of sight. These people face incredibly challenging lives, even extremely simple tasks like navigating their own home, trying to find objects that they've placed down only maybe a few moments ago that have shifted, are almost insurmountable tasks for these people to accomplish. And right now, the current devices that exist to assist these people, we believe are insufficient. They face drawbacks like canes require contact with objects, and existing sensors are limited in their area of effect.
Right. So we asked ourselves a simple question, which was, how can we assist these people in interacting with their world without necessarily having to touch the objects around them? And so we came up with our solution.
And our solution is Touch Plus, which will let you experience the invisible. So I would like to ask, please, Brandon, if you could explain to people what Touch Plus is about.
All right, everybody. As you can see, I have a very fashionable Connect on my arm. This is Touch Plus version 1. What do? First of all, I'm going to take you through how it works. We start in a resting position, hand slack. When the hand comes up, the sensor, which I'm sure you can all hear it buzzing because of your really great hearing in the audience, begins to start pulsing at a frequency that is determined by the distance of objects in front of me. We get this distance with the IR sensor on the front of the Connect. Now, when I move this to a point where something is closer to me, this frequency increases with the distance. This allows us to have real-time tactile feedback with no touching like canes need, with a farther distance than canes could ever achieve. Also, a lot more accurate since it's a digital sensor. Now, you see, the Connect is a little bit bulky. Revision 1. Revision 2, we want to take only the IR sensor out of the middle, place it right on the front, and that gets rid of this tether, the annoying thing on my computer. Next step. As you may see, I have the Myo armband on. This armband does more than simply recognizing when I want to sense by flexing my hand, and when I want to stop sensing by putting my hand down. The orientation of my arm in space is used to determine the threshold at which this starts to beep. For instance, if my hand is up, it's as if I'm looking far into the distance, and changes of large magnitude will result in changes in frequency. However, those changes of large magnitude won't help me if I'm trying to find an object on my desk. So, if my hand is pointing at a lower angle, as retrieved by the Myo armband, it will be able to sense the differences of objects on my desk with the same precision as objects far away. This transition between close and far is instantaneous and seamless. Now, that's what the Touch Plus is, but I want to talk to you about what it will be. We envision a world where being visually impaired is no longer something that affects so many people. With the Touch Plus, we can change the lives of 285 million people in the world right now and allow them to experience the invisible. Thank you.
All right, up now we have the Force Ghostwriter, and Soteria, you are on deck.
Hi, everybody. I'm Vamsi, this is Akshay, and this is Conan. So our project starts from back this winter when we all watched The Force Awakens, and while we all loved the movie, we couldn't wait for the next one to come out. And then we found out that it got delayed by another 6 months. So we were like, screw it, we're gonna make our own scripts, we're gonna make our own movie. So enter the Force Ghostwriter. The The Force Ghost Rider is basically a recurrent neural network that we've trained on the scripts of the Star Wars movies that we've gone online. And we've trained it to the point where we can actually generate scripts and basically dialogue between characters that are novel and we created on our own. And now Akshay is going to take it away with some technical details.
All right, thanks. So basically, this is an overview of our model. This is a recurrent neural network. Specifically, we're using a long short-term memory neural network trained using Google's Tensor work that was recently open sourced a few months ago. It allows us to do some pretty intense data crunching on some Amazon GPUs, which helps us train this model efficiently. But let me just walk you through the details of how this works at a high level. Essentially, what our model sees, it doesn't know anything about the English language. It doesn't know anything about words. It doesn't know anything about characters. All it sees are these characters one at a time, one letter by letter, and it interprets them as a one-hot vector. Basically, what we want to do for this neural network is we want to generate predictions for what the next character is going to be based on what we've already seen. And we represent that context of what we've already seen in the hidden layer. Now, literally speaking, the hidden layer is just a vector, but it represents all the context that the model has seen so far. Things like what the topic of the sentence is. Things like, is it at the beginning of a word or is it at the end of a word? Is it at the end of a sentence, and if so, should it put punctuation there? All of this can be encoded in these hidden layers. And they feed into each other so that over time, as it observes more layers, it updates that hidden context based on what it's observed. So for instance, as we're training, we want to be able to pipe in, say, the letter H, go through the hidden layer, and then come up with a classifier that will be able to tell us a probability distribution for what the next letter is going to be. We can then sample from that distribution once we've trained our model and say, okay, this time we found E as the most likely thing. And then we write that down. Then we pipe that through, update our context, and see what the next prediction is. And we keep on going like that, and pretty soon we've generated an entire new screenplay for a new Star Wars movie.
All right, so now I'll give you some real details, or comparison actually. So right here we have script sample 1, and then right below it we have script sample 2. Unless you're a speed reader in the audience, it's kind of hard to tell from an immediate glance which one was the one we generated with our model that was trained overnight, and which one was the one that's actually a sample from the original script. And you can probably guess by now, the bottom one is the actual sample script, and the top one is what we generated. But the interesting thing is that this type of recurrent, like LSTM, recurrent neural network, is able to learn not only words, sentences, and paragraphs, but it understands structural syntax. Can you hold it to the top? Yeah. Structural syntax like indentation, tabulation, how the length of paragraphs, how the average length of a dialogue versus the average length of a description of a narration at the beginning of a scene. It understands that a scene starts with all caps, external dig of a day. I mean, that's something that was generated from the script. Whether that actual scene setting ever occurs in the actual scripts, we checked, it doesn't actually. But the thing is, not only that, it now knows that you have words, but the words are represented further with nouns, people, and so it has external dig of a day as a setting, and then it says you have these characters like Rey, Chewie, Rebel, Leia, and if anyone has seen any of the movies, you know none of them go together in any scene at all. So the thing is, this is something that's dynamically generated, and yet it has the semblances of grammatical structure. Obviously, it doesn't make that much comprehensive knowledge, but this is something that was obvious, that was off of a very short training, and we think that with more time we could do this better. So a really quick real-time demo.
All right, well, we're technically out of time, but so if we wait, basically if we wait like a few seconds. Just click it. 10 seconds. Okay, 10 seconds. So right there we generated live. We generated a script from a seed parameter and also a text length parameter. And as you can see, it has a lot of the features that Vamsi just talked about over there. And so thank you.
Up now we have Soteria. Soteria, please come to the stage. And on deck is Portnort. If you are ready, let us know.
Hi, we are Soteria, Aditya, Yes, Piyush, and Rono. We are from Johns Hopkins, and many of you are also from Hopkins, and you are aware of the security risks of being at Hopkins. Lately, we get a lot of emails saying that there are robberies going on, and a couple of weeks ago, we even got an email that there was an attempt kidnapping. So we thought, okay, we have to do something about that. So we built this app that allows a user to be tracked by the security guards. So we have two things. We have one, the iPhone app, and we have the control screen that is controlled by the security guards. So when a user wants to get tracked, so he wants to walk home at night alone, he will press the button Guard Me. He can choose a destination or just select his home address, which he did enter earlier. So once he gets guarded, he shows up on the control center, and in the control center you can see where he's heading. So when they are tracked, the control center can warn some guards nearby to keep extra attention. But of course, if really something's going on, you want to press an emergency button, which is also on the app. So once you press the emergency button, you will switch in red, and the security guards know that they have to send someone over. Of course, getting your phone out when you are in trouble might be hard. So we have built one more thing. It's the Pebble app. So the Pebble app basically does the same thing. It also have a start and stop tracking and an emergency button. Once you press it, you also show up in the control screen. So for the moment, it works all live, so you will be tracked. You'll see the movements of someone walking around. So we built our front end using AngularJS. We have an iPhone app. In the backend, there is we have a Node.js backend running on Amazon Web Services. And the Pebble app is built with JavaScript Pebble library. That's it.
Thank you very much, Soteria. Up now, we have Portnort on the podium over there.
It would be ideal. No, it has a VGA, so I mean, if you
All right, guys. So while they're setting up in the meantime, the HopHacks organizers actually have a raffle for a free Mayo armband, which is right up here. Wouldn't that be cool? Okay, so I am randomly generating 5 people from the list of registrants. And so if I call your name, the first name I call, I'm going to go down the list, and the first one who is here will get the prize. Does that make sense? Cool. First one, we have Cameron Robinson. Are you here in the audience? Cameron? Andrew Wong. Are you here, Andrew? No? Archon Patel. Hey, there he is. Congratulations, man. No problem. Oh yeah, what are you going to build? Anything. Touch Plus, right? There you go, there you go. Touch Plus. All right, Ryan, did you want to do domains? Cool.
Do I need the mic? Is it for audio? Oh, okay. All right, awesome. So I need 2 seconds to set up. Give me 1 moment. All right, guys, I'll be speaking again in a moment when we're finishing up the ceremony. Right now, I'm just going to do the domain.com prize and the AWS prize. There's a ton of great hacks I saw this weekend. If you guys didn't get your iDemoed stickers or anything like that, just come talk to me. I'm going to start with the AWS prize. So I'd like to invite the Force Ghostwriter back up to the stage. They won 4 Dell portable hard drives. Congratulations, guys. There's only 3 of you. My bad.
Thank you so much.
Let's pose for a picture real quick, guys. All right. That's again. Good. All right. And the domain.com best domain prize is always a challenge to judge. Thanks to everyone who ended up getting a domain. Our winner is JHU Course Visualizer with the domain coursehops.com. Are you guys here? Woo! Congratulations. And they'll be winning domain.com swag bags that I think have t-shirts in them and a whole bunch of other mystery stuff, so.
Okay, so while we're waiting, I'm actually going to call up the sponsors to give away their sponsored prizes. So I have a list of them up here on the dock. All right, are the sponsors ready to give away their prizes? Thumbs up all around? Great. Okay, to start off with, we're going to have Bloomberg giving away the Sphero app-enabled BB-8 droids for easiest to use hack that helps a broad audience of people. So we'd like to welcome Bloomberg to the stage.
Hey, my name is Wolfgang, and I'm with Bloomberg, and I'm on stage here with Harish and Bina and Tuvia. First of all, I would like to thank every one of you. What we've seen this weekend is incredible, as every weekend we come back for HopHacks. Just the creativity and the innovation, the technical things that you show us is always great to see. Secondly, I would like to thank the organizers for setting this up for us. They always do a great job. It's great being here. And lastly, I would like to thank my team for being here with me. They also did a really great job. We had about a little bit more than 20 submissions, so judging this time was quite difficult, especially given that we had such a broad definition of what we were actually giving out. So we let ourselves guide us a little bit by the values of the company as well. So we went with philanthropy, health, public safety, personal safety, but also with things like technical difficulty and how much the product was done. So with that, we actually have 3 winners, 3 to 1 basically. And the remaining pens that we have that made it somehow through the quizzes, we'd like to give to the 3rd and the 2nd place. So the 3rd place actually goes to Overwatch. The 2nd prize goes to CSI. And then the 1st prize, which is an app-enabled droid, goes to Soteria. So Soteria, please come to the stage.
All right, up next we have MedImmune. MedImmune, please come to the stage.
Hello, everyone. I'd like to thank the organizers. Very impressive. My first time here on a HopHacks. Mind blown. Some really, really cool stuff was seen here. So our challenge was a little bit too specific. Nobody really picked up the challenge per se, but there were some really impressive contenders in the same area or general area of what we're looking for. So we have actually a mention.
So
there you go.
we're going to announce first, second, and third. We've got prizes for first and second place.
Right.
So we're going to go in reverse order. So the second runner-up that we want to recognize is the team called Open Tracker for their Zika virus and generally incident plotter that ties into social media. So congratulations. Okay, and now we'd like to call up the first runner-up. The team is called Wellspring. This team integrated EPA data with other quality metrics, for example, air, UV, etc. So can we have Wellspring come up? Are we bring them all up?
Yeah, well, first so we have a couple of GoPro heroes for you. You have to decide how to split between the four of you. Okay. With memory cards, so you can actually film your whatever you want to film.
Did you get a picture of that? Okay,
and
thank you. So the winner for the category that we've selected is called CSI. They parsed and displayed clinical trial data, which allows patients, individuals to enroll in trials. So can we call these guys up, please? Where are they?
CSI.
We also have certificates for the winning team.
So we have 3 GoPro 4s, one for each of you, with memory cards. There you go, one. Sorry, grab one of these. One of those. Yeah.
Yeah, just the last thing we want to say is that, again, we were really impressed with, all of the projects that the teams that participated in our category. They're all, very relevant projects and very important for social reasons. So we'd like to encourage you guys to continue to develop your projects. Thank you.
Thank you, Madam All right, I'd like to call Google up to the stage to give away their best use of Google API prize. Google, please come to the stage.
Hey everyone, you all built amazing things. It was so cool walking around seeing everything that got built. I absolutely loved it. It was really hard to pick just one winner because there was such great uses of Google APIs across the board. You guys used maps in really cool ways. There was some TensorFlow. There was just some great stuff. So the winner ended up using TensorFlow to build Star Wars scripts, and it was amazing. So, yeah, Star Wars Ghost Rider. Round of applause. One apiece. Thank you.
All right, thank you, Google. Up next, we have, MLH already gave away their prizes, so book holders over here, please come to the stage to give away your prizes.
Hey guys, how you doing? Let's first have a real good round of applause for all the hacks you guys did because they were awesome. And let's have a round of applause for all the organizers and everyone who put this together. It is tough to put together a hackathon. It requires a lot of work, a lot of hours, and they did a great job. All right, so first I'm going to read off the coolest use of hardware, and we had some really cool hacks with hardware, but the one that really stood out is Touch Plus. So they get a choice of Raspberry Pis or Spark Photons, and hey guys, yeah, I'll go, when you guys are done at the end, come by in the back, and I'll give you all the stuff. Congratulations. Right? Okay, and our grand prize, can we get a drum roll for half a Bitcoin? Come on. Sotera. Congratulations, guys. You guys did a great job, right? Right? Okay. And come in the back after. And I'll pick you guys up. So once again, you guys did a great job. We have internships for spring and summer, so check us out. Thanks a lot.
Thank you. Thank you very much, book holders. So in the interest of time, and in order to get our judges to the next stage of the round, I would like to invite the judges up to see Portnoy. Unfortunately, we could not get the HDMI display working, so the judges were going to have to kind of crowd around Portnoy over there.
Can you just give it one
So
more
apologies to the audience if you can't see anything. Hopefully, Harsh can do a good job of explaining what is going on to the audience.
Dan, can you just give it one more shot? Come on. Nope. Sure, yeah. No, the table.
Just have we're going to have the judges move over.
So, I mean, I'll still be speaking, so you can all hear. So, so there were two guys. I mean, we worked together on. So first of all, hi, we are Portnoy. It's a short of portable snort, but then it has a couple of other things apart from snort, so I missed the S. But anyway, so my other teammate Mason could not be here. He had to rush to TC, so he did write a write-up which I'll read out to you, and then the technicals I'll just let you know. So here it goes. Portnot. Harsh and I are both master's students and at GUC. So we are always thinking about security. Unsecured connections make us cringe. Forms without validation make us tear out our hair. And thought of manual memory management leaves us cowering in the corner. Worse than all of these specters, though, is an open Wi-Fi connection. Putting traffic on a public network is a nightmare. Anyone with the internet access and a quiet conscience can read it, and anyone with a little expertise on top has a good chance of being able to exploit it. However, not all people have the luxury of being able to remain online. In a sad piece of irony, such public networks are regularly used by people who have the most to lose. With this in mind, we created Portnot, a simple pocket portable network security solution. For the prospective user, it's a simple device. One simply connects Portnot to the Wi-Fi network, then connects himself to the Portnot. With that simple gesture, she has given herself all of the protection we have hidden under the hood. Should one wish to pry Portnot open, however, he would find a great deal more. First, a whole host of simple network hardening tricks. This layer includes things like checking the MAC of a router to ensure it hasn't been spoofed, filtering out reverse path packets, and ignoring ICMP redirects to prevent man in the middle. Second, an aggressive firewall which blocks invalid TCP flags, optimizes DNS queries, drops suspected trace routes, and blocks outbound malware connections. The keystone piece is, however, the Snort Suite, an open source intrusion prevention system capable of real-time traffic analysis and packet logging. Together, these systems create a level of security superior to that which nearly any user enjoys when working from his own home, or even from many small offices. Portnot is particularly well suited to businesses, business people, doctors, lawyers, and anyone else who needs a security solution but finds the current offerings too complicated, too expensive, or simply too bulky to bring on flights. Portnot, common sense in a box. So thanks, Mason. So all right, so basically Portnot under the hood is a Raspberry Pi. The catchy feature, so if I may just pull it across, this is our device. So right now you might see a lot of wires coming out of it, but the actual solution is just a Raspberry Pi with a battery attached to it and two Wi-Fi dongles. The concept is that one of the Wi-Fi dongles would connect to the non-secure Wi-Fi, like Starbucks Wi-Fi, airport lounges, and then that internet connection would be routed via NAT inside, and a hotspot would be created, which would be the secure hotspot. The catch over here is this NATing happens through Snort and through the firewall that we have implemented using IP tables. So apart from giving, as Mason already said, apart from giving, oh, okay, so I'm running out of time. We'll quickly give a demo. So this is Snort running. It is loading all the rules, and it is creating, based on the rules that we have written, some of them, it is creating a rule chain, and then it'll start listing. The attacker, my dear friend Cyrus over here, is trying to port sweep the Wi-Fi, the IP of the poor guy. So what we have put Snort in promiscuous mode, so it'll just tell you, it'll just give an alert. Just press enter. Here you can see the alerts coming. So it's in promiscuous mode, so it is not going to stop it, but it will show you the alerts, and these can be logged and used in retrospective later on. Thanks a lot.
Thank you, Portnoy. All right, so now we have the top 10 finalists have presented. The judges may retire to the judging room. And in the meantime, we're going to present the remainder of our sponsor prizes. All right, so the first one is .tech. They don't have any physical representatives here, but the winning team will also receive $50 to each member that uses, if this is assuming their hack uses a .tech domain. The second is IT at JH. Could you please come to the stage?
Hey, how's it going? We had a great time. I mean, just wowed by mostly everything that happened this weekend, and tired. Not nearly as tired as you guys, but still tired. So we have, I'm up here with my team from ITHH, Kirk Sibnani, Irene Zivagelski, our Director of University Information Systems at Hopkins Central IT, Anthony Gato, Senior IT Manager, and Sam Livingston, a Senior Software Engineer. And so thank you for allowing us to be here. It was run impeccably. I was impressed. I think everybody was. We have 2 prizes. Our first prize is going to a team that used our API. So the JHU course visualizer, please come on up. And you get your choice, right, between a drone and a Chromebook. Oh, decisions. Drum roll. Come on, guys. Which one do you want? Of course you do. Thanks, guys. Great job. Nice work. Thank you. Thank you. Thanks a lot. Thank you. Oh, we got to get a picture. Picture, everyone. Thanks, guys. We'll be in touch with you. All right. And you'll have to figure out who gets it on what weekend. Okay. All right. All right, we have another, so we have the Chromebook, not that it's second pickings, it's still an awesome prize. So Satara, I don't know, you're up here again, so nice work. We really were impressed with the safety of your app. Thanks. Thank you very much. Thanks. Thank you. Thanks. Thanks a lot. Thanks a lot. Thank you. Congratulations. All right, we gotta get a pic. All right. Thanks a lot, everybody. Wherever Dan is, there's Dan. Come on, Dan.
All right, guys, so that was actually the last of our sponsor prizes. So we're going to have to sit tight and wait for the judges to finalize their deliberation. So I'm just going to put on some music. We're just going to chill for a little bit. Again, I apologize for some of the delays, technical difficulties. Hi, guys. It appears the judges have made their decisions. So if we could cycle back into the auditorium, we'll get started in a few minutes. Thanks. Thanks. I'll go first. All right, everybody. We have our top 3 teams. Can you believe that? After 36 hours, this has come to the final moment, and I'm going to hand the mic over to our judge to announce the top 3. Here we go.
Thanks. Once again, my name is Dan Roach, and what an incredible pleasure it was to judge this. I hope you all had a tremendous time. I talked to many of you, and you know what you guys accomplished in just a weekend. Some of it was just truly amazing, just absolutely truly amazing. So I'm really looking forward, dear, to announcing the awards. And third place goes to Touch Plus. If you guys recall, Touch Plus was the folks that had the handheld device that they were aiming a target market of the blind to be able to help. But as you can imagine, that could be used in a lot of other different ways with a lot of other different types of devices, and could have one heck of an interesting future. So congratulations to Touch Plus. Drum roll for second place, which I think, yeah, did an incredible job as well. Tip of the tongue. Well, they had a surprised look on their face when they when that was announced as they came down. But a very interesting and I think potentially useful app. Great simple design, and everybody's looking forward to go home and playing with it, especially with the Urban Dictionary piece. Congratulations, tip of the tongue. All right, and the biggest drum roll for first place. Here we go. Drum roll. Citeria. Here's an app. I want my own personal version where I have each of my kids tracked, and I know exactly where they are and when they're coming, and it's safe along with. So I want not only that, I want my own personal version. Congratulations, fellas. Well done. Thank you. Nice app. Get your picture there. And you guys get one heck of a present, too. So once again, the awards were third place was $256. Tip of the for Touch Plus. Tip of the tongue gets $512. Soteria gets $1024 plus some interesting hardware to go with it. Yeah. So thanks everybody. Congratulations to all of you. Great hackathon. Great job, guys.
All right, guys, real quick before everyone heads out, I just wanted to give another shout out to all of MLH's sponsors. We could not power hackathons without the help of Dell, Intel, Domain.com, Capital One for the awesome spring t-shirts we got, and of course, Amazon Web Services. My guys who just won first place, come see me afterwards. I have Dell Venue 10 tablets for you guys to pick up. I want to thank all of the organizers. Without them, we could not have this event. So let's have one more round of applause for the organizers. Awesome. And as a final closing note, if you have hardware that you borrowed from our hardware lab, I will be heading over to the hardware check-in area after closing ceremony. Please don't leave with my hardware. I would like it back. Thank you, guys.
Thank you, Ryan. Yep. All right, thank you so much, Ryan. Guys, before you head out, we have a few final announcements. Make sure to grab all your things from Hackerman, Malone, and this building. If you're missing anything, there's a lost and found outside by the breakfast area. Winners! If you are in the top 3, please come see Joanne with her hand up over here. If you want your money, you have to see her to fill out some information. In addition, buses are leaving around 3 p.m. See Diana in the back. Diana, can you raise your hand? Please meet her, and she will lead you outside to take the buses home. And again, you can contact us at hophacks.com or hophacks@gmail.com if you have any issues with transportation. Thank you all so much for being here. Thank you.
go.